All right, so this is Note-Taking Guide 3.2 on geometric series. So what we're going to do is we're going to just find the pattern like we did yesterday to start out. So continue this geometric sequence below. 1, 2, 4, what's next, guys? 8. Then what? And how are you finding those?
It's geometric and the thing is 2.
Yeah, so geometric, which means it has a common ratio. The common ratio is 2, because how did I get from here to here? I times by 2. How did I get from here to here? I times by 2. So I'm following that same pattern up the whole way. So give me the next several numbers so we have them. What's the next one? And then? Good. Good.
256.
Yeah, and it just keeps going, right? Do we got one more we could put here?
512.
512. Thank you. So we totally can just keep going, and really the ... means we can go forever. Okay, does anybody remember from yesterday's note-taking guide what I said these little subscripts right here mean?
They mean the term there.
Yeah, so what term is this asking for right here?
The x or
The first term, right?
No.
This right here says, what does the first term equal? Well, the first term equals, what's the value of the first term? 1, right? And did you already find the common ratio for me? This is what this R stands for today. Is that common ratio? And what's that common ratio going to be? 2, because we times by 2. Okay, questions on the notation of how this reads. So this says the first term. This is the common ratio. So if I asked you that, what am I asking you? The fifth term. And what's the fifth term? Okay, everybody's following the notation? We're good to go on that, right? Okay, so what we're going to do today is we're going to talk about series that are called geometric. So the ones that have that common ratio involved with them. So a geometric series is the sum of all of the terms in a sequence. The sum of the first n terms is called a partial sum, and that's because we're not summing all of the terms, we're just summing a certain number of them. And it's denoted S sub n, meaning the sum of the terms up to m. So it will say, maybe if I said S of 4 right here, this would be the sum of the first, how many terms? 4 terms. So what does sum mean? Add, right? Sum means to add. So what would we do with the first 4 terms? We would add them together. So right here, it says, using the sequence above, find the partial sum. What's the sum of the first 3 terms up here? Well, the first 3 terms were 1 and 2 and 4. So the sum of those terms would be 7. You following me on how that works? So the sum of the first 6 terms would be 1 plus 2 plus 4 plus 8 plus 16 plus 32, which would be a total of, it's a what? 63. Okay, so that's not too hard to do, right? If it says the sum of the first 3 terms or the sum of the first 6 terms. But what if I asked you to do the sum of the 71 terms? Anybody want to add 71 numbers together from that series? After you find them, right? Because we haven't even found them all yet. Do you see why a formula would come in handy here? Okay. So this is the formula that we're going to use to find the sum of however many terms we're looking for. Okay. The A1 stands for, who remembers what it stands for?
First term.
The first term. The R stands for the ratio. The N stands for, which is the only thing that we don't know yet, the number of terms that we're looking for. So if this said the sum of the first 8 terms, what would our N value be? It would be 8. You following me on how to use that formula? So we would put in the first term times 1 minus the ratio to the number of terms power over 1 minus the ratio. And it just turns into algebra from there. Okay? So here's an example that's already done for you of using that formula. It will say find the sum of the geometric series if A1 is 2, meaning the first term is 2. We're going to sum the first 8 numbers, and the ratio is 5. So they just substituted those numbers into the formula where it went, and we simplify the top and simplify the bottom. If you punch it in your calculator as a fraction this exact way, it will go and find the answer for you. So you would be able to go and get this answer just from here if you punch it in the calculator the right way. So the sum of the first 8 terms in this series is this number. So let's see if we can do it ourselves just by subbing stuff into that formula. So the first thing I'm going to do is just rewrite the formula because I don't want to be confused as to what I'm doing. So here's that formula from the other side of the page, just rewritten down. Now this particular problem just gave you the numbers to plug in. So we're just going to practice plugging in those numbers. So we're finding the sum of how many numbers? 8. So this just represents the sum of the first 8 numbers, right?
How do we find that? How do we know?
Because it told me that n had to be 8.
If they don't tell you, how would you?
Oh, they're going to have to tell you in one way or another, and I'll show you on the next few examples how you're going to be able to see that, okay? All right, do we know what our first term was? They told us it was 2,000. Do we know what our common ratio is? It's 1/2. Do we know the number of terms? We do. It's 8. And then on the bottom, you'd have 1 minus the ratio again, which is 1/2. You guys, when you're doing your math on this, you might want to keep that separate, or that middle part, do the parentheses first. You can enter it your calculator that exact way, but I like to do it in parts because of the crazy 1/2 right there. So I would raise that to the 8th power and then do 1 minus that number and then times it by 2,000 and then divide it by this down here, which would be the 1/2 again. But you guys do it on your calculator however you want to. When you get the answer, tell me what you got. That's exactly what I got. Did everybody get that answer? Did anybody take the time to plug it in besides Colin? You just going to believe your calculator can do it? Okay. All right. Good enough for me today. All right. Example 2 right here then says find the first term of the geometric series, which means we're actually going to be solving for A1 this time instead. Okay.
So is this done now?
What?
The last problem's done?
It's done. Yep. That would be the sum of the first 8 terms on the last problem. Yep. Okay. All right. So really what they want us to do is, it says find the first term of the geometric series if S of the first 7 term, or the sum of the first 7 terms is this, and R is 3, the common ratio. So using this information, do you know the number of terms that we have? It's 7, right? So what's your n value? 7. Do you see how they kind of hid it there from you, but they gave it to you at the same time? So they told you how many terms there were that we were looking for. There was 7 terms. So then this time they subbed their information to the formula, but this time we're solving for that first term. They gave us all the other information. So when we do it this time, we have to simplify this side first so that we can isolate the variable. So they simplified the top, they simplified the bottom, they divide this to figure out what that number is, and it was 1,093. Then to get the A1 by itself, if it was times by that, you would have to divide it to the other side to find your first value. So again, we're going to do an example of our own just like that, where we're looking for the first term instead of looking for the sum. So the very first thing I'm going to do again is I'm going to write down that formula so we don't get confused.
Should we just, and just to start, should we just write n equals whatever it is?
Yeah, so that's a good question. Colin says, don't I need to know what n is? Well, we do need to know what n is. What is our n value going to be on this problem?
6.
6 because they gave us the sum of the first 6 terms, and n is going to be 6.
Yeah, I was wondering if you could
Okay.
write it down when you started.
Yeah, I was getting there, but yeah, I always like to write it down so I don't forget what it is. Okay, do we know the sum of the first 6 terms?
Yeah.
It's 5,824. Do we know our A1 value? No, that's what they asked us to find. Then we're going to do 1 minus the ratio, which they gave us, of 3. And we're going to raise it to the number of terms power, which is 6. And then on the bottom, we'll have 1 minus the ratio again, which is 3. Okay. So really, you guys, what you can do right here is punch all of that in your calculator at once as a fraction, as long as you put the parentheses around it where I have the parentheses around it. Okay. What'd you get? 361 or 4? I can't hear you. 4. So, did anybody else get that 364 so we know that that's the right number? I'll check mine just to make sure. All right, what's our next step there?
Yeah.
Yeah, I got 364 too.
So it's times it.
Yeah, because it's times by right here. What am I going to do to get rid of the 364? I'm going to divide it to the other side. It cancels over here to my A1, and over here on the other side I get 16. So what was my first number? It was 16. If I wanted to know my second number, I could find it, because what was my ratio? It was 3. I could times this by 3 and it would give me my next number. I could times that number by 3 and get my next number. So sometimes, you guys, when I am like, did I do that right or not, I will find my first 6 terms and add them together to make sure that I did it correctly. It just depends on how confident I'm feeling on my work. But the first term on this is 16. Questions on that? All right, so this is the exact same thing we've been doing. It's just written in a different notation. It's called sigma notation, okay? And it writes it like this. So it says we're going to find the sum of, anybody know how many terms we're going to find the sum of here? Well, we're going to start with the first term and we're going to go to the 4th term. So we're going to find the sum of the first 4 terms. That's what it's asking me to do here, okay? So it's called sigma notation. It's really no different than what we've been doing. It just looks a little bit different. This, anybody know what sigma means? Sum. It's just the Greek word for sum. Yeah. So why is it called sigma? It's a letter in the Greek alphabet and it stands for sum. So here's what we did here. We're going to find the sum of the first 7 numbers that go into this formula right here. So what we are going to do is use that exact same formula that we've done before, but we're missing some parts to it. The first thing I was missing was my first term. To find my first term, guess what I have to substitute in? 1. So that's where they